Assalamualaikum warahmatullahi wabarakatuh. My name is Irina Batrisha binti Muhammad Zamri, matrix number CF190143. So today I will be talking about our Civil Engineering Mathematics 4 group project. The topic that we chose is application of numerical differentiation. For this project, we are going to talk about 6 things. The first is introduction, second, Phyla table, third, literature review, fourth, methodology, fifth, result, and lastly, discussion and conclusion.
My name is Haryanti binti Mohsin and I will continue with the introduction for our topic, application of numerical differentiation in UTHM road safety during peak hour. In numerical analysis, numerical differentiation describes algorithm for estimating the derivative of a mathematical function or function subroutine using value of the function and perhaps other knowledge about the function. Numerical analysis is a branch of mathematics and computer science that develops and analyze and implement technique for numerically solving continuous mathematics problem. Such issues arise from real-world application of algebra, geometry, and calculus, and they involve variables that change on a regular basis, as this problem occur in the natural science, social science, engineering, medicine, and business. As for background of study, numerical differentiation is a concept from a discipline of civil engineering that we have related to our study topic. As a result, we picked the traffic volume research to evaluate the number of cars passing a piece of road per unit time at any given time. The unit for traffic count is generally taken as vehicle per day or hour. The unit of measurement for traffic counts is typically car per day or hour. As for problem statement, the issue statement for this study is to conduct research on traffic engineering, with the problem mentioned being the number of cars that utilize their indication when passing through the roundabout in F2 region. Not only that, but we have also see how many various sort of automobile utilize the indicator when approaching the roundabout. Finally, during peak hour in UTHM, the number of cars utilizing the indicator at the roundabout indicates the safety of the road. As for objective of this study is to study to determine the objective from the above mentioned issue statement. That is, 1. To measure the number of vehicles using the left or right signal at the F2 roundabout. Secondly, to observe various vehicles using the signal at the roundabout. And lastly, to determine the road safety at peak hour in UTHM by the number of vehicles using indicator when turning left or right at F2 roundabout. Moving on to the content number 2, Phyla table.
First of all, I would like to introduce myself. My name is Cho In Yoon and my matrix number is CF10220. So I would like to present about the Phyla table. So from here you can see that there are 4 facts that we all have obtained. So first is the number of vehicles using indicator in UTHM during peak hour. And then the idea we get is need to develop the numerical equation method. For the learning issue is how to develop the numerical equation method, and the action we apply is by applying the numerical method learned in the civil engineering mathematics 4. So for the second, the different type of vehicle using indicator. So the idea is to need to discuss the type of vehicle that use indicator. So for the learning issue is how to determine which type of numerical method is the most suitable. And the lastly is the action is by using the trial and error in different numerical method. So third is the number of vehicle that use indicator using during 60 minutes of impaction. So need to determine the percentage of vehicle using indicator. So for the learning issue is how to determine which type of numerical method is the most suitable. So for the action that we have uses is by multiply the result with 100% to get the result. So lastly is the apply numerical method in differentiate equation. So the ideas we get is need to determine the percentage of vehicle using indicator, and for the learning issue is to how to determine which type of numerical method is most suitable. So lastly is the action is by using trial and error in different numerical method.
Next, me, Karenisa binti Muhammad Isri, CF190119 will explain the literature review. Modeling real-world problems at multiple scales. During the driving process, each driver has his or her own personality, which is determined by the goals of being fast and avoiding accidents. Drivers unconsciously drive in such a way as to avoid traffic congestions on the roadways at all times. Again, we require the assistance of a mathematical model that can provide the essential understanding to make the life of drivers more comfortable. For numerical differentiation, differentiation is a fundamental mathematical procedure having numerous applications in a variety of fields. It is crucial to have good methods for computing and manipulating derivatives. Ordinary differential equation, partial differential equations, and integral equations are the most common mathematical models used in the natural science and engineering. The approximating equation has a discrete set of places where it may be solved, and this solution approximates the original problem. The first one, finite difference formulas for derivative. The difference quotation of Newton known as a first-order divided difference. In either case, the difference quotation is known as the two-point forward difference formula FDF for f prime x if it is used as an approximation value of f prime x. Thus, the two-point backward BDF and two-point central difference formula CDF are defined in terms of the functional values fx minus h and fx, and fx minus h and fx plus h respectively. Secondly, two-point finite difference formulas and Euler's Taylor series approach. In this section, we will illustrate how to use the Taylor series and state without proof to derive the two-point difference formulas and the truncation errors associated with them, as well as the three-point FDF and BDF. Two-point FDF and BDF versus three-point CDF. Two-point FDF and BDF are OH. They are first-order approximation. Three-point CDF are OH square. This is a second-order approximation. Three-point CDF is more accurate than FDF and BDF. This is because both two-point FDF and BDF are OH, while two-point CDF is OH square. The third one is three-point and higher order formulas. Three-point FDF and BDF approximate f prime x in terms of the functional values at 3 points x, x plus h, and x plus 2h for FDF, and x, x minus h, x minus 2h for BDF respectively.
Moving on to the fourth one, methodology. For this project, a study was conducted to solve the problem of ensuring road safety during peak hours in University Tun Hussein On, Malaysia. It was done by observing the amount of vehicles and motorcycles that use signals at a road junction located in the UTHM campus. The data collected was obtained from a statistical research from the traffic engineering subject. The research was conducted from 8 a.m. until 10 a.m. at a road during peak hours. Based on what has been learned in Civil Engineering Mathematics 4, the number of vehicles percentage using signals can be calculated using numerical differentiation. By calculating the data using these formulas as shown, the percentage during the observed hours can be obtained. The equations that will be used are listed as in the slide.
Let's take a look for the fifth component, result. Problem calculation. Table 1 shows the data of cars and motorcycles obtained for the interval of 15 minutes. There are a total of 120 minutes used for this calculation. Now let's take a look for the calculation of data for cars. Use h equal to 15 and t equal to 60 minutes. We do example for two formulas. Two-point forward formula FDF is f prime x equal to f in bracket x plus h close bracket minus fx over h. Now we can substitute all the x and h values. The result for 2-point forward difference formula FDF is 40%. The next one is 2-point backward difference formula. BDF is f prime x equal to fx minus f in bracket x minus h close bracket over h. And we can insert the values of x and h. The result for this formula is 180%. Next one, moving to the 3-point central difference formula, CDF, the result is 70%. Next, 3-point forward difference formula, FDF, the result is 43%. Moving to the next one, 3-point backward difference formula, BDF, the result is 310%. And the last one, 5-point central difference formula, CDF, 91%. Now we are doing for the calculation of data for motorcycle. Again, we use h equal to 15 and t equal to 60 minutes. For the numerical differentiation, the first one, 2-point forward difference formula, FDF, the result is 33%. 2-point backward difference formula, BDF, the result is 73.3%. 3-point central difference formula, CDF, the result is 20%. 3-point FDF, forward difference formula, the result is 46.7%. 3-point backward difference formula, BDF, the result is 123%. And the last one, 5-point central difference formula, CDF, the result is 26.1.
Moving on to the sixth one, discussion and conclusion.
For the discussion, this study is to determine the number of vehicles that use indicator in University Tun Hussein Malaysia by using the numerical equation method. So from the experiment conducted, we found that from the first derivative fx for 5-point center difference at t equal to 60 minutes, the percentage of car using indicator is 91%, while for the motorcycle is only 26.1%. So from here you can see that the percentage of car using indicator shows that the probability for accident to occur is very low, while for the motorcycle is very likely to happen. So by comparing both results from the two different type of vehicle, we can say that there is still a number of road users that do not comply with the rules of road safety. So from here we can conclude that a high percentage of cars are still considered safer than the motorcycle when driving because they have abandoned by the rules.
In conclusion, approximate values at 60 minutes should be able to be obtained by calculating using the suitable and right formula contained in the numerical differentiation topic. The formulas that can be used have been listed in the methodology slide. Based on the calculation of the data, the answer obtained from f prime x for 5-point central difference indicates that the number of cars that use signals at road junction are higher than the number of motorcycles. The values obtained from the calculation were 91% for cars and 26.1% for motorcycles. From the study, it can be seen how much the drivers and the riders obey the basic rules of being on the road. Since there are a huge gap between the two results obtained, it can be said that there are more improvements that can be made in the way how drivers and riders act and behave on the road, especially at road junctions in a campus. This is so that any undesirable accidents can be avoided much earlier since there are a lot of students that walk by foot in the campus area. It is much better to avoid than to cure. That is all from my group and me. Thank you.